Hello, welcome everybody to Shohoz T3, Tomorrow's Tech Today. I am Topu Newaj, Senior Vice President Shohoz. Today, I have with me Ravi. Today we have Ravi with us. So Ravi Garikipati, he's board member of Shohoz, and he's also co-founder and CEO of Divanta Financial Services, and also the biggest thing is that she was the ex-CTO of Flipkart, the unicorn of India, one of the largest startup that went into $1 billion. So he was CTO in that, and today we are very proud to have him with us. Ravi, thank you very much for joining.
Thank you for having me, Topu, and I really appreciate you inviting me for what will be hopefully an interesting session, and I'm looking forward to interacting with the tech community out there in Dhaka and other parts of Bangladesh, hopefully from outside of Bangladesh as well. I was told a short while ago that there's some youngsters out of university and academia also likely to join, so look forward to it.
Yeah, amazing. Yeah, so first, I gave a short introduction to you. Maybe you can introduce yourself, and then I will probably first introduce myself. So I'm Topu Newaj. Maybe some of you know me. So I was currently the Senior Vice President of Shohoz. Before that, I was CTO of Celis, a Swiss company, for 8 years, and before that, I was in CAS Software. That is one of the largest outsourcing company in Dhaka. So I'm an architect, software engineer, mostly .NET engineer. Worked all my life in .NET, and yeah, here we are trying to rebuild the Shohoz infrastructure, the backend services into .NET now, and handling a lot of data. And one of the biggest discussion today would be how to handle that kind of data. So Ravi, I introduced to you a bit. So if you want to tell us a bit more about you and your career, that would be great. Ravi, could you hear me? Hello? Hello? I think we are having some technical difficulty at Ravi's end. Let's hope he can get back soon. Yeah, so he's gonna rejoin.
Yeah, I'm sorry. I don't know what the problem was. I'm blaming the internet vagaries here, and I will not take too much time, and I want to get started with the interactive session. Briefly, Raviji, people call me Raviji. Now Topu must have figured out calling my last name is a challenge in itself. I've been in the technology, and I've been a technologist and entrepreneur for the last 30 years, and primarily, being part of consumer tech companies, and last 3 gigs have been very, very interesting to say the least in terms of the scale that we achieved in the organization that I've been part of. The latest being Flipkart, like Topi mentioned. We have close to about 150 million install user base across tier 1, tier 2, tier 3, the geographies of India. And we'll get into it a little bit later, some of the data nuances associated to building a web scale architecture of that magnitude. And currently, I'm looking at disrupting financial services for underserved, underbanked in India. And it's called Davinta FinServe. It's a fintech for bottom of the pyramid. That's a short summary of what I do.
Okay. Great, yeah. So thanks again for being with us. So yeah, let me start with like how I would like to approach this. So we at Shohoz, we are a very small startup, I would say, like compared to anything that has been widely successful. So, but even with us, we can see that it's very different than traditional enterprise applications that we are handling here. Because me personally, I come from enterprise application background, so I have built enterprise applications all over my life. But when I've come here and when I'm trying to build applications for the crowd, for the mass people, the scales are pretty much different, very different than what it used to be. So for example, we have a ride sharing service, and if we, for example, have 500,000 riders on the street, and each of them are sending their location each 5 seconds, and that's already a lot of data over a period of a day, over a month, and a year. And then all this data needs to be like received, processed, stored, and then we have to run different kind of queries on top of it. So, and then like later we need to process this data for other kind of things like analytics and machine learning and stuff like that. So it's a huge different ball game than anything that we have seen before. Like in information age, data is being told that is the gold. So I mean, everything you need to extract every information out of it to make better judgment, better decision, better engineering, better business calls, and so on. So everything depends on data. So I would like to ask you, like, from your previous experiences, how this whole thing starts, like all this data coming in, what do we do with it? It's this big challenge for us.
Yeah, absolutely. And I think this challenge is magnified in the recent past, ever since there's a proliferation of the smartphones and internet had become ubiquitous for every consumer, regardless of where he is in the economic strata. So they all sort of sharing something or the other with a service provider, whether it's a Shohoz, Flipkart, Amazon, what have you, right? So take a step back. 20 years ago, when I was in Silicon Valley, I was part of a couple of database companies. IBM, back then they had a relational database called DB2. And then fast forward for a few years later, I joined Oracle at their headquarters, and we built a relational database, largely focusing on transaction databases for OLTP processing, online transaction processing, ensuring data coherency and consistency and integrity and things of that nature, and providing subsequent response times for Wall Street kind of applications. And then suddenly, 5 years later, during my stint there, we realized there's a strong demand for what now we call data warehousing or OLAP and that kind of application. Suddenly, people realized even at these companies like IBM and Oracle, look, OLTP database in and of itself is not going to be good enough to serve that kind of needs. You need this whole concept called, we didn't call it data lake and what have you. We didn't call it big data, but there's this, loads and loads and heaps of structured data over a period of time can be humongous to store it in the relational database and at the same time do both analytical processing and also OLTP. So let's actually come up with this concept called data warehousing, and where we have a clear criteria what kind of information topics we want to delve into and who are the target audience we want to serve, right? And what kind of a data time frame that we need to look at. And the things of that nature actually lend itself to figure out what part of this humongous data that we need to take it off from OLTP and move it to what we call as data warehousing, and then start coming with the different data models that are more amenable for ad hoc querying and what if analysis and so on and so forth, right? So, and that was still okay for a structured data, right? And that was almost 15 years ago. But with in the last 10 years or so, when people are building these apps that have a tremendous traction, and you have a few tens of millions of users using this app, and you have all kinds of data, not just structured data, unstructured data, qualitative data, quantitative data, and they are running into a few terabytes of data in a given day, depending upon who you're referring to here, and they add up to a few petabytes of data. That was clearly the case in a place like Flipkart. Now, to actually lean on to a framework that I just alluded to some time ago, which is we have OLTP and data warehousing, just not going to cut it. So we have to look at completely different ways of actually harnessing the data, right? So that's when I know nothing that I say is out of the box, but there's a lot of people who embarked on this journey, whether it's Facebook or Google or many such web scale platforms. Some of them actually very generous enough to learn from their experiences and contributed that into open source forms. The people like us leveraged it. So over time, what emerged is something called Lambda architecture. Some of you are very familiar, I would imagine. Essentially what it's saying is, in order to harness data of that magnitude, you can't have one size fits all architecture. You clearly, if you sort of want to abstract your data needs, they are actually of three types, right? One is what we call as real-time data. You do a real-time decisioning, right?
Yeah.
Another one is near real-time.
Yeah.
Another one is near real-time. You don't, maybe a lag there is anywhere between 2 minutes to maybe even 30 minutes, but these
like
are counters.
Warm data probably, yeah.
Absolutely. And the third one is real batch data, where your data scientists, your analytics folks will look at it.
Like that can be like maybe past month's data and so on. Yeah.
Exactly. So basically, can we come up with an architecture that addresses all these three? And that's what is popularly known as Lambda architecture, right? And I've actually been part of two companies which dealt with a humongous amount of data, unstructured and structured. Before Flipkart, it was 24/7.ai. What we built is again a big data platform to deliver AI-driven customer experience for big clients like Verizon, AT&T, and Walmart, and Sears, and Macy's and stuff like that. So where data was rich. So what essentially Lambda architecture does is basically there are various data sources in our application who are emitting data, right? And those are the event producers which are emitting data.
Yeah.
So we basically have an architecture which basically takes this data, it persists in what we call as this big batch data storage, and there's a real-time data which is largely a streaming kind of an approach. The data is being streamed to this streamer. Back in those days, I used something called Storm. The data producers are Kafka like event producers.
Yeah.
And then basically the data is replicated both into batch data and the real-time streaming engine. So the real-time streaming engine, what it does is on the fly, it was computing certain metrics, right? Aggregating certain things, and then making it available for business and operation guys to do real-time decisioning, right? And then there's also application needs where we need to take some of this real-time data, aggregated views, and some from batch data, and then that is a blended view that application use, which has the complete context, right? So that's the common architecture. We can get into the nuances of how do you go about building and all that. So if you look at most of the companies which has a web scale kind of a data, that's a common architecture. Topu, they call it a batch layer, they call it real-time query layer, and the third one is service layer, right? So these are the three layers that they have in that architecture, and that's what we built, right? Yeah. And but then there again, the devil is in the details, right? When you look at batch data, the common thing is that this is the structured unstructured data. Common thing is basically come up with a Hadoop like grid. It's a distributed HDFS clusters, and that's where you kind of put your data. And then for batch data, you do a typical map reduce kind of a job to divide and conquer your workloads, and then you come up with certain a transformed data view which can be imported into columnar databases like HBase or Cassandra, or even some cases relational databases, right, to do your querying, right? And analysts will actually look at that. And whereas for real-time thing, we largely process data was persisted in Cassandra like stuff, and then most of the business applications were looking at that. Those were the things. And again, the reason why we chose that is both for a batch and the real time, these are horizontally scalable, right? And they're largely relied on commodity hardware, right? And most of it is open source driven Apache software frameworks, right? And that lot of folks in the community, people such as Google, Facebook, and Twitter, they've actually tested it for a stress, for a scale, and for real loads. And so that's what we embarked on, right? And that largely held us in good stead. And we can talk about some of the other things, right? The web analytics and the likes of I don't know if you're familiar with Adobe Omniture and Google Analytics, and they have a slightly different architecture. We can get into that later. But at a very high level, that's a standard, most popular architecture to serve the kind of needs that you have for a web scale platform, right? I'll pause here and take follow-on questions on that.
Yeah, excellent. So so that's like a, I mean, I really don't even see that kind of scale yet in the current architecture I'm working with. But let me discuss a bit about, like, maybe I will tell you something that we are doing, and you can tell me that if you're doing it right or not. So
sure.
Right now we are actually trying to build a completely new architecture for Shohoz, and this is a completely event-driven microservice-based architecture. So we have these different subsystem microservices. They're actually taking in command and emitting events. So all these events are running through an event bus, and then there are different listeners listening to these events from that bus. So that is the base architecture of that we are building. So let me take back that same example that I presented in the beginning. So for example, we have all these location information coming from all these riders. So what we need to do now, that first of all, like when we have our users, they're looking for a ride, we have to provide them a list, or maybe a best possible driver in the vicinity of that specific user. So we need to use special query on that. So to do that, what we're doing, we're bringing all this location data from the drivers, and then first we are putting them into an in-memory kind of store where we can do really fast geospatial queries. So and then that same event is listened by another system that is putting through a queue, and then maybe a bit later persisting it into a location history system where all the different locations are being stored. So the in-memory database, we are actually using Redis here, the in-memory database actually stores only the latest location of that driver. So it only contains the latest location of all the drivers where we can run our geo queries, and then the historical location of this user of this driver is stored in a completely different database, which can be used for many different kind of things for a later purpose. So are you talking about something like that? Like does it map back to
absolutely. It's very parallel to what I just described, right? Essentially, you have a real-time thing. You persisted in memory, and for all the real-time decisioning, and then you again sort of have a batch for offline analytics. You persisted another data storage where you can do a bunch of analytical decisioning, right? So yeah, very similar, and that's what we have it. The scale may be a little different. And that's where when you do that, you have to pick up a computing architectural paradigm that's horizontally scalable and that can work on commodity hardware. That's the key here. And but otherwise, it's very similar, Topu.
Yeah, exactly. So like moving towards this direction, I mean, we are just starting and building this system. So like, do you think this event-driven architecture that we created, will it support us down the line? So for example, maybe when we have like 1 million orders a day and so on. So like, what kind of challenges do you think we're going to face with this architecture? Do you have to rebuild it at some point when this eventing will not work, or like how do you think it should be addressed? Like, I mean, is the right way to go, having this event-driven microservice of this architecture, or we need to figure out something else at a later point?
No, I think like I said, right? I'm pretty sure that's what your architecture designed for as well. The way I see it, these in our case, we actually used open source again, Kafka event producers, and defined these events, and each microservice is emitting, and then and we actually have a logical cluster of certain services, under one Kafka cluster, and there are multiple such things, and there are multiple Storm event processors. Listening, you call it listening to those events, basically listening to that stream of events coming from different clusters, and they are horizontally scalable, right? And And so we like I said, today we collect close to about 12 terabytes of data. I mean, when I say we, I'm still referring to Flipkart, right? And it's scaling very well. And on day one, when we put together architecture, our data gathering was probably 1/10 of what I just mentioned, right? So it's organically scaled to this limit, and we haven't necessarily changed any parts of the architecture, right? Absolutely. That's why I say this lambda thing. Even the company that I worked prior to Flipkart, which was 24/7 day, I put it in place in 2010, and we had the same thing. That we built in Flipkart as well. And I know many people, whether it's Uber or a bunch of other guys, have a very similar architecture. They might give different names, but under the hood, what you're saying and what I'm saying is very similar.
Yeah. So moving forward from here, so all these different technologies and Hadoop and all these things that you said, like now the cloud providers coming up with different technologies as well. For example, Amazon has a huge tool set that is they're providing for this kind of big data technology. So what is your like perception here? So do you think we should like host this kind of technology and like build on top of that? Or instead, we should just take the technologies provided out of the box from this Azure and AWS in a way that we really don't have to consider building Hadoop and this kind, because Amazon and AWS and Azure both are providing similar distributed file systems, like ST, Amazon Athena for querying engine and data lake technology and so on. So do you think that should be the right way to go, or we should try to like build our own technology? Bring in.
Yeah, that's a very good question, Topu. And this is where one should not be emotional. And I know all of us are technologists. We pride on building everything from ground up, and the tendency is let's do it, and we do it better. And we try to justify that call by saying our requirements are very custom, very specific. Our business is very different from others, right? Or we'll probably at scales save a lot of costs, save costs as well. No, these are typical arguments that are put forth, and leaders such as us look at it, and sometimes we get swayed by that, right? Trust me, these things do take time, right? And there's the opportunity cost here, right? And unless you're really convinced that you have the scale already with you, and you really have that total cost of ownership coming down significantly, right? It's not worth the trouble, right? To your excellent point, all these public cloud infrastructures, whether it's AWS, GCP, or Azure, with no exception, have something or other that is equivalent to what we just described, right? And we should absolutely leverage that. And they also addressing very emphatically all the concerns that we have around security, right? And data privacy, and so on and so forth, because they're also under the garb of a government or a regulatory framework. So they absolutely have to comply to some of those data privacy and security guardrails, right? In fact, they do a far better job. They're far more proactive, and then address all the vulnerabilities versus us doing it. On a good day, we focus on all that. On a bad day, we have other things to do, and these things are not well addressed, right? So short answer is absolutely. Look at some of those things that are out there. You have to have a real good criteria as to why you need to do all this stuff yourself from ground up. And is your requirement so specific that gives you a disproportionate advantage to your business from a competitive angle, where you have to build that yourself, right? Or can you, even if that is the case, can you build it quick enough for a business to take advantage of the solution that you are putting together? If you say I do it, but then I'll take a year's time, in this day and age, year's time is way too much, right? Right. And some of these things will take time, especially when you talk about building from ground up, right? So even I'll tell you one example. We actually literally built what S3 is all about, right? The object storage infrastructure, right? We used Ceph and some of the open source stuff. We built it in-house, to address storage for object and block and file systems. I don't know, if I look back now and I say, why did I do it? And one lose excuse or lose justification. I mean, I don't want to, slam my own decision. Oh, that is served by Amazon, and Amazon is our competitor, right? So, so we don't want to keep our data there, right? Stuff like that. There's some, So, but
Yeah,
if you don't have any such,
yeah, exactly. I mean, maybe you can make such decision at that scale, you know, like, I mean, for us, no, we that's totally out of question within the size that we are currently in, and we are definitely totally dependent on this cloud.
And absolutely, I completely encourage you guys and all the folks on the call, you know, absolutely, you know, evaluate the offerings that are provided by these cloud infrastructure providers. Some of them are good in some space, some of them are good in some other space, but you can do the evaluation between the three and then pick the best one that suits you.
Yeah, excellent. So now I will try to bring in a different aspect to it. So I mean, if we look at the security and personal information within the data, so how to address that? Because I mean, a lot of the data that we have, it has personally identifiable information. We have phone numbers, we have name, we have addresses, and then when we put this data through these different pipelines and it goes to different places, there's always a question of security, vulnerability, data breach, and so on. So how do you think? I mean, we are already struggling. For example, there are different information, there are different process within our organization where we have to say, for example, we want to send SMS to a specific set of users. And then when we are sending that user, the person who is actually doing the sending of the information, we want him to not to be able to access the, say, for example, address of that person. So we need to like somehow like segregate, isolate, and like deconstruct the data in a way so that only specific portion of the data is available to the specific. How do you address things like that?
Yeah, there are three, largely there are three areas I briefly touch upon. One is, of course, let me just latch on to the point that you brought up, right? What I call is fine-grained access control, right? You have all kinds of data, right? And you absolutely have to have a good understanding of what are different classes of users you have in your ecosystem, and what kind of data is permissible from an accessibility standpoint. And you define your fine-grained access control grid, and then protect access to data accordingly, right? That's one. The second thing, to your point, is PII data, right? It's one thing to say you have access to this and so on and so forth, but there's also, you know, willful, breaking into the systems and, you know, capturing some of this PII data, whether it's external threats, internal threats, right? No matter how you define a fine-grained access control, there's a propensity to break into that, right? So you have to put one more layer, right, to protect that PII data. So what we, you could say that, let me actually encrypt entire data, and then, and I have a decryption key, and that is, not tenable. It's very consuming, and it's not worth it, right? At least the PII data, we should absolutely encrypt it and do it, and that's something that we embarked on 4 years ago. And the third one that we need to do is this. Now you may be hearing it more and more ever since the fact that now the endpoints for application access is many. The zero trust approach, right? Zero trust security. That means if you're accessing an app from somewhere else, your rider is accessing, or your driver and streets of Dhaka is accessing your app, and so there may be some perpetrator out there in I don't want to slam Eastern European guys. Some perpetrator out there, want to hack into your stuff and access the data through your app, and then take all the vital customer data, and then they can misuse it, right? So now this zero trust is like, you have to authenticate yourself, right? There are a lot of zero trust. Amazon is doing a bang-up job providing you that layer. If you host your application, you don't have to invest into any other stuff, right? So you have to do that. You have to do fine-grained access control. You have to encrypt at least the PII data and things of that nature. And and that's what I recommend.
Okay, so let me tell you something that we are trying to do, because I'm trying to just justify some of our decisions that we have made in our little context that we have. So what we are actually doing is that all these different events that we're listening, what we're trying to do is trying to create different kind of persistent views of that data for different stakeholders. So for example, we have different kind of users accessing the data. So when an event is being raised or like emitted, the same event will be listened by two different event listener, And one event listener will strip out some of the information and store only the portion of this data that's relevant for the specific stakeholder. And the other event handler will probably store a more detailed version of data but this puts us back in another position that we have too much replication of the data, like same data is stored over and over and over. And when something changes, for example, when some data is changed, then this ripple effects through the entire system, that maybe if we have to update, I don't know, maybe a city name is updated, for example. Like it doesn't happen too often, but if it happens, all this replication puts us into a big trouble of updating all this information stored into very different places. So like, is it a good approach that we are taking of like having different view of the data, or I don't know, like what is your thought about it?
Yeah, so prima facie, based on what I heard, it doesn't seem like the right thing to do. Maybe devil is in the details. So, but what I hear from you, if you're replicating data to address that specific problem of restricting access to certain data elements for certain set of users and certain data for certain set of users, there are better ways to skin that cat, right? And I would still actually move everything in one central location. And then I'll have different views derived out of the central thing and mask certain data, right? And these are materialized views, right? Underlying data is the common thing for all of them, right? So if there's any data change, like city name is changing or XYZ is changing, you just go change in one place. And then since each user group will have access to certain view definition that gets materialized real time, so you will only have access to those set of elements, right? That's that's probably a better way of doing it versus on what you just said. And you also mentioned that I think in your question you also articulated, I'm not quite sure that's the right way. I think your instinct is right. That's not necessarily the right way.
One of the biggest challenge here that when we are building this microservice-based architecture, what we have decided that each of our microservice will have their own database. So for example, so in that case, when we have having all these different microservices with their own databases, some data would definitely need to replicate, because for example, we really don't want to have service-to-service communication too often on the back end, because that makes the latency too high. Because when I have to request for some data, then the backend service has to make another call to a different service to get a portion of the data, and then create a more complete version and return it. So what we decided to do is that based on these events, different microservice will store a copy of the data into their own system, and from there we are actually providing some sort of a query service that allows you to we have introduced things like row level securities of the data, the column level securities of data. So but even with that, the actual data, all the data are not in a single database. They're distributed over different databases, and we still have this problem that when something changes, we have to emit an event that, hey, city name has changed. So all these different microservices, they're storing some kind of city name into their system, has to listen to that and update it. So I mean, that doesn't happen often, but it happens, and then it puts us in the spike situation where all these services are trying to make modification of millions of rows which had the city name in it. So yeah.
So again, common problem, and the share nothing kind of an architecture is very common, right? You can have a localized data store or a data in that particular node and share nothing type thing. And then, but then to your point, there'll be instances where you do need to have certain common data store, right? And so what we've done is basically we do have a common data store that are accessible for all the data services, right? While we have a share nothing kind of a thing, maybe 80% is just we have all the data in the local data infrastructure itself. For this 20% of the time, they still have to go to this common data store, right? However, there'll be a time when it's not just a replication issue that I need to address. Sometimes, I may have to take that cost of replicating data in order to provide better response times, right? Exactly. If I'm So what we do is we basically replicate this data in all these nodes, right? from the shared infrastructure, from the common data store. And whenever something changes, CTR, these events are defined and they get triggered, and they proactively push it to all this stuff, right? But then we don't do it across the board thing. We are very careful what information is frequently accessed, that they need to persist in the local storage itself, even if it means I have to replicate that. What I can afford actually going to the server across the network and get that information, right? So we make those calls, and accordingly we do that. But to your larger point, most architectures are shared nothing. I think you're right. You have a class of microservices. They require certain data stores. They're all there in that cluster and shared nothing. That's the way to architect.
Yeah, so we're actually trying to do that. So have like shared nothing, have all the data to yourself, and each microservice. I mean, we actually have created we're trying to create like a multi-tenant system. So for each of the service, for each of the tenant, we actually have a different database. So all the different tenants having their own database to store the data. So yeah. Actually, like, I mean, it's great to have this discussion with you, because, like me and we have now Nobel with us, and between us and our architects, we are making all this decision. And it's sometimes like we question ourselves, are we making the right decision? Because we try to study, and then sometimes when I talk to someone like you, I get a bit of like confidence myself that, okay, like I'm not doing things really wrong. Yeah,
absolutely. That's how we learned it as well. Yeah.
So thank you very much for that. So moving on about data. So we are trying to focus more on NoSQL databases. A lot of our data is stored in NoSQL databases, but then there is still SQL Server and MySQL kind of relational databases, and it sometimes becomes a bit difficult for us to make a choice that shall we sometime use like a SQL or like transactional database as well, because we are very much pushed towards NoSQL, and it's right now it seems like we SQL databases are a bit of like we really don't want to use them. They're like the things from the past. They're like dead, and we really go into that. So what is your feeling about relational database? Are they still a thing, or we are fine with NoSQLs?
Yeah, good question. The use cases for relational database has become very crisp and finite, right? If you're looking at pure transactions, right, and you want to maintain a transactional integrity and maintain the asset properties, and even if it is a distributed thing, you have a distributed transaction integrity. We still have a role for a relational database. It comes with some of those things inbuilt, right? And NoSQL, it's basically for performance and higher throughput, and not necessarily transaction, all non-transactional stuff, right? Even me computing real-time counters to do some decisioning in the operations front, right? That I don't call it a real transactional application or a transactional business case, right? Those things will still be in a columnar database. The reads are efficient, and you get much better throughput and performance, right? But hardcore transactions still, you need to sort of pick a relational database. That's something that we've done.
Yeah. Okay.
But the cases are very finite, though. Very finite.
Yeah. So so talking about transaction, let me go a bit towards that, because maybe a bit tangential. So we are having this, like multi-service architecture, and we are really sometimes we struggle to how to maintain a proper transaction that is distributed over different services. So we are using patterns like Sega pattern. So we have a Sega that is actually controlling the service decisions, and then it is trying to execute one service, then another, and then another, and if one fails, then it tries to undo the other. So this kind of Sega pattern. So do you think, like, in having a like relational database, and for example SQL Server, which provides distributed transaction out of the box between different instances of database, do you think, like, instead of having this kind of Sega pattern, which is a service level transaction management, and then we have this database level transaction management, so do you think like we can choose one over the other?
Yeah, it's a good question. It's a good question. It's a bit. Let me think about it. Both essentially serve the need. One is abstracted at a service level, another one is down at the data level. Um, so how do you make that call, right? End of the day, both should give you that integrity, transaction integrity, and if something fails, you should be able to roll back you only commit that when all the services ping you back and say that to the orchestrator saying that I'm good, I'm good, I'm good. Then you sort of otherwise you
Yeah.
roll back and all that stuff. So I don't know, Topu, it's a real good question. As long as they're meeting the same need, yeah. In one case, the reason why I will choose database is I'm lazy enough not to build that. It's already comes built in, right? A two-phase commit or a distributed and transaction integrity, or it saves me from the nuances of orchestrating that through my service framework. I will do that. Otherwise, there's no legitimate case to stick with that. Right? If you already made that investment, you do that. Are you inferior doing that? Absolutely not. You absolutely provided the same capability.
Yeah, exactly. Yeah. Yeah, no, because we did that. We have our own Sega orchestrator, and it's handling all the transaction between different services. And
Yeah,
then we
you're good. You're
ask
good.
questions that like, are we doing the right thing? Should we have, because like the Sega orchestrator are quite complex. It contains a workflow within it, and then based on different state, it performs different operation. It's this. I mean, architecturally, it's really like very pleasing. If you want to build something like that, it's very nice to build.
Yeah.
You are proud of it when you build. Yeah, but then again,
that's right. That's right there a point, right? You have fortunately someone like you and Nobel and few other smart guys, and you could think through and put together this orchestration to ensure the integrity across the distributed nature. If let's say on a startup on day zero they don't have that competency, right? It happens. So no one has that competency on day zero. Then they have to rely on what's tailor-made for them, what's readily available, and there's nothing wrong with that. But you have it and you built it. So absolutely, there's no. I mean, you're not losing out anything. That's good.
No, that sounds good. Yeah. So I feel much better already after this session today.
Yeah.
Yeah. So yeah, moving on. Regarding this data, we are currently using a lot of MongoDB to store our data for the the operational, the transactional data that we're producing in our system. And then we are still in a way to like put this data, taking it out of MongoDB and putting into other sources. So if I ask you that, do you think the choice of MongoDB was a good one, or what other alternate data sources or databases would you propose that we could use?
Yeah. So and what actually it depends on the kind of application character. It depends on application characteristics, usage patterns. Is your application purely transactional? Is it read heavy, or is it a combination of both the read and write? Right. And some of is read consistency important, or availability is important. Things of that kind. There are bunch of it's not a one size fits all kind of decision, right? It depends on what kind of characteristics that your application has, and what sort of usage patterns you have, and then accordingly make the choice. And personally, this is where at least during my time, most of the the transactional database store has been MySQL still, right? We are a little old in that regard. And around the time I was actually moving out, and a lot of architects came and pitched to me, look, let's democratize some of these choices, and it can't be command and control from one central team. So some of the subsystems started using MongoDB, and they kind of justified why they had to use that versus going with MySQL or some other stuff. Some use even Postgres, right?
Yeah.
Some you could sit and argue that hey, they all sort of provide the same thing, that they have the replication, they have high availability, they provide transactional integrity, but then each one has certain nuances that they do better than others, right? So it'll go back to that one particular thing that architect is big time selling to his engineers and to even the CTO for that matter. And you have to make that call. Is it really, because otherwise the issue that I was trying to grapple back then, why I was a little pedantic and saying, just stick to only these 2-3 databases. Think about it, right? It's not just about giving that luxury, or I won't even call it luxury, that privilege to architect to choose whatever he pleases. Post that, right? Fast forward 4 years later, right? You have these disparate tech stacks in your organization, right? And to manage and administer and do the performance management, performance tuning of various. You have to have those kind of capabilities, right? God forbid if it is done on the back of one guy who understands that. If that guy, for some reason, he is pursuing some academic interests overseas or whatever reasons, right? He chooses to move on. You are left with having to manage a disparate infrastructure. It's not easy, right? And all these guys, come with the new versions and changes, the upgrades, and it's a nightmare, right? To that extent, right? I try to keep it to one or two to the extent possible, keeping in view the long-term maintainability.
Right. That's a very, very good point, because I mean, with this microservice architecture we have, sometimes I've been told that, hey, I mean, each microservice could have used their own completely own database, and you really don't care.
I'm sure they will. Architects will romantically debate with you as a CDO, and they will more often than not try to prevail. But you have to say, hey, it's not, that's one side, but there's a downside of this. Let's balance this out. Let's not overly optimize for short-term goodness, but you have to look at it long-term as well.
Yeah, true. Very true. Yeah. So that's I mean, we are still trying to stick with MongoDB where as possible. In some cases, we are using, for example, for in-memory databases, we decided not to. I mean, we cannot use MongoDB for that kind of fast query, so we decided to use Redis for in-memory database. And for some other cases, we probably have to use, say, for example, Elasticache. And
and that's, see, those are good examples, right? So Elasticache has certain use case that it Redis as well. Redis addresses certain use case like in memory, and transfer for OLTP transaction need. There are certain database choice. So you do thorough analysis of all the options available. Pick one stack, right, and try to standardize on that, right? So now you're not saying everything you need to make do with the MongoDB itself. You have a different classes. But let's say in memory you have 10 different databases. Don't give an option of architects picking 10 different choices. Then it's a nightmare for you to manage all that.
Yeah. So great. Yeah, amazing. Yeah. So that's so far. I think we are still saved. We are pretty much focused with two, three different databases and not more than that. I would like to ask you something more. It's a bit tangential to the. I mean, building these microservices. Do you think that we should bring in different technology to build these different microservices, or we should also use the same logic here and try to be within at one or two technology that we're currently using and stay with those? Or maybe, I don't know, like one is built with Node.js, another is in Go, and another is in, say, Java. So shall we go towards that direction, or you think that that should also be constrained by the same logic?
Yeah, I would apply the same logic, Topu. I know unless there is a compelling need, the Go, it gives you the XYZ and some other thing, or I can multi-thread it. I can, maybe certain aspects of that particular stack is far superior for my business case. They have to really justify, right? Otherwise, we have to stand. If you already have a legacy, don't force too much to transition everything to one, because that legacy that will take its own time and it has to come at the expense of not taking care of some other business hours, right? But once you figured certain tech stacks that you're going to hang your hat on, after taking into consideration what kind of business you're building, what kind of technology you're building for what kind of business, then as much as possible you have to rationalize to your architects and engineers, let's stick to this, guys, right? And for the same reasons that I called out before, right? Otherwise, finding these competencies across various tech stacks is also going to be a challenge. So that's the maintainability and all that will be an issue. Finding talent will be an issue. So you have to, I would agree.
Okay, so yeah, I mean, we are almost at the end of the discussion. We have just about 10 minutes. So let's go through a bit of the questions that we have. I see one question from Rafi Mahmood saying, like, it's not a question, more of a statement, that webhook can be a handy option, replicate all the data in different database of different microservices. Yeah, Rafi, definitely webhook can be used, but the way we are currently trying to address is that it's more of a bus and message driven architecture for replicating data. So instead of the data replication, what you said, that when some data is changed, the source of the change should actually call a webhook and send the data to the other system. So that actually creates a direct like dependency between these two services. The service one has to know the URL or location of that webhook that the other service. So instead of that, we could completely make it decoupled. The service one actually posts a message into a service bus, into a queue, or maybe an exchange, and the other service actually listening to that exchange and getting the change and updating itself. So webhook definitely is a solution, but having that kind of makes us coupled. I mean, this is one big nightmare that anybody you can take a look into Google, and go into Google and do a search with Netflix microservice architecture. There's a picture there. That's like a nightmare picture. Like Netflix made a decision to make service-to-service calls, and the service-to-service calls made them have like 2,000 services, and one service is calling like 300 different services. A huge network of service. That's very not maintainable. This messaging-based architecture is a bit better than that. So yeah, there's one question from Razaul Russell. I would pass this question to Ravi, that what is the best database for real-time data management system?
What is the best database? So we used Cassandra, right? We took NoSQL columnar database, and we used Cassandra. Largely, we done. I think back then the architects had looked at few other options, and we needed a sub-second response time to be. Primarily, what we were use case there was, we have a lot of machine learning models that we deployed in a production environment, and we needed to basically look at the user and build a user profile context, not from the legacy data, but based on some of the stuff that we did on the website, and the events were emitted, and whether he's looked at certain category and browsed certain product pages, and added certain products to the cart. So these were all emitted, and then we needed to sort of basically do real-time lookup into a database such as Cassandra for a quick sub-second response time, because the decision had to be made not even sub-second, it's a few nanoseconds, right? So when we did all that stuff, that held us in good stead, right? I'm not sure if there are many other databases that came in the recent being that beat that benchmark that we had conducted. So our choice for real-time decisioning was Cassandra.
Yeah. Okay. Great. Yeah.
Yeah. So, personal experience. I will put a caveat. There may be other databases. I'm a little dated.
Yeah. Exactly.
Right?
No, that's always true. Yeah. But these kind of things are always very, very personalized. That truly worked with, you got comfortable with, and it gave you results.
At that time,
yeah.
T1. At the time, T1.
Exactly. Yeah. Yeah. So there is another question that is coming. It's a statement from Razibul Islam that Elastic Search is cheaper than Redis. It probably is. We have to take a look into it. Elasticsearch, and maybe it could be cheaper than Redis. So we didn't take a look at it, but we will. So then another question coming that from Zunaid Hussain, saying that what are the best practices with running analytics processes and reporting on data, not just fixed report, but ad hoc queries. Yeah, so I mean, you know, like there are different kind of analytic queries needs to be made. So what can we use for that?
Yeah, so I think before you actually talk about any tools, and I think the important thing is to focus on how you actually construct ad hoc the database for ad hoc querying, right? So typically in a big data scenario, most of the data is sitting in HDFS, right? Distributed file system across multiple clusters, and so we have to then write a few jobs to transport that data or transform that data. It's a little bit like ETL, extract, transform, and load into a certain database. In our case, we used HBase, right? And then because we are able to do a much higher reads and another, and so our query efficiency was higher because it optimized. IO reads are much lesser in HBase versus any other database, and then we can actually abstract an end user layer, right? These are views that we call it, right? And then on top of those views, we can provide visualization tools. Visualization tools can be a third-party tools, right? It's challenging for you to build your own visualization tools. But this the backend processing that I'm talking about, that's largely something that you need to invest. You create the TTL process on the Hadoop grade, transform into transport into either HBase or some other database, and then create end user layers, which are views, right? And then a bolt visualization tool. And the visualization tool should be, not a pre-canned reports. It should be what if kind of a thing, right? And there's a lot of tools out there for a visualization. And in fact, even AWS and Azure and all these guys provide a lot of third-party ISVs who also do that stuff. And there are many, dime a dozen out there. I think the important thing is not on the tool, how you architect your data lake. And there's if you don't do it properly, your performance is going to be so bad that your end user will pretty much give up.
Yeah, I mean, in the same direction, I have another question from Hira Hassan. He's saying that shall we use tools like Power BI and Tableau, or should we build our own system? So in
my case, I use Power BI, but Power BI is the end user tool, right? But behind that, all the heavy lifting that I did, you still have to do it. And then Power BI will get bolted on top of that to do all that stuff. So if you are asking me, I have a very good understanding of Power BI. We have actually used that, but that is not to say that's the only one. There may be other tools, and if you ask me, Power BI, it served my purpose for varying degrees of cases that we have in our user base. It did.
Yeah, perfect. There is a very interesting question from Sajjad Abul Hasib, that is Cap Theorem breakable? So some people are doing research about it. I didn't know about it, that they're doing research on that, and can be found in different blogs. So yeah, I mean, if I would address that, I mean, I have been like pitching Cap Theorem and domain-driven architecture in our local market for last 4 or 5 years, and every places I have given session to, I all try to explain the Cap Theorem. So let me explain it a bit, like maybe in 2 minutes. So I mean, the Cap Theorem is a theorem that says if you're building a distributed system, then there are 3 things, and you can only choose 2 of them. So the one is like consistency, availability, and partition tolerance. So you cannot have all 3. You have to choose 2 between them. So partition tolerance is that in the distributed system, you have to assume that the distributed system networks will breach. So there will be network breaches between them. So partition tolerance, you have to build a system that has to be partition tolerant. So you have to pick that anyway. So if you pick the partition tolerance, then you have an option to pick any one of the 2. Either you take availability or you take consistency. If you take availability, then you have to let go consistency, because your service is available, but based on partition tolerance, the data you are getting from that service could be stale data. So it could be data that is because the network breached, you do not have the latest data from that node. But if you take, say for example, consistency, then if you go to a node and then based on the as the network is already breached, so that node will not provide you data. It will not provide you data because it has a chance to give you stale data, but it will not because it's consistent. So it will stop giving you data. So you either choose consistency or availability. And I really don't see a reason how this can be. It's like law of thermodynamics to me, it seems, that because the anyway network can always breach and there is no possible way to make sure that partition tolerance with partitioning will never happen. We always have to be partition tolerant. So I really don't know how that can be achieved. So Ravi, you have any comment on that?
No. Beautifully explained, right? And in fact, somebody asked me, what did you use for real-time database in Flipkart, right? I used Cassandra. Again, that's the choice that I made. I went for, in this case, availability, right?
Yeah.
And HBase would have given a better read consistency for me, right? Yeah. And availability was important for me, and I made that conscious call. And yeah, as far as I'm not privy to the research work that's being done in academia, but I'm with you in terms of your articulation.
Yeah. Okay, so that's pretty much it. We are on time, 9:30 here, 9 o'clock at your place. Ravi, we will not keep you anymore. Thank you very much for joining. I always would like to come up with like good reasons to bring you back again, and because this was very
anytime.
But because like I mean, if you look at all these different discussions having in local market, I see most of them are very superficial discussions, like CEOs coming and talking about like different business that I really don't like those, like I really wanted to have a very hardcore technical discussion with someone, and that we tried to do in the last session as well, and this one.
Great.
So I really want to have like very technical hardcore discussion that really provides insight into tech that people can take notes from and start implementing things by taking this note into his own system. So
absolutely,
absolutely.
Thank you, Topu, and I really like your passion, and you are a technologist at core, and someone who understands business as well. So I think technologists who comprehends and understand business, he makes all the right choices and wise choices as well, and he is not overly romantic about one tech stack. He's a lot more pragmatic in his choices, and of course. I learned a lot interfacing with my peer group in Silicon Valley, who had the fortune of embarking on some of these things and learned as they embarked on this journey. And similarly, India is a little bit ahead of what you guys are doing in certain technology investments, and absolutely feel free. And that's how we promote a very homogeneous tech community, or harmonious. Harmonious tech community that is borderless, right? And another day we build rock solid platforms and technology that will enable and propel businesses to serve the end customers as well as we should.
Yeah. So yeah, thank you very much. So my CEO picked up the line that I was saying that CEOs are talking bullshit, and I got immediate message from her. So I've been caught a bit. But yeah, I said what I said.
Yeah. Okay, all right. Good night, guys. Take care.
Yeah, thank you very much. So I will let you go, Ravi. But before ending this session, I have two things to say. First is that we're going to do more of these. So please follow the Shohoz Facebook page, because we're going to publish more of these into there. If you follow them, you'll get to know. It's very difficult to reach out everybody. I tried to send 100 messages to my colleagues to publish this. And the second thing is that we are hiring. And we are building this amazing architecture, amazing software. So if you are interested in building this great architecture that we're currently working on, please come with and work with us. We have a lot of positions open. We have front end, back end, all positions open. Please contact us. Please talk to our HR and come and work with us. Thank you very much, everybody. Thank you, Ravi.
Yeah, thanks.